Hello, so welcome to today's video. Today we're going to be talking about how Satan and God are living concepts and cannot be described using specifics with regards to what they look like, how old they are, how they behave, but we're going to be exploring them as living concepts. And to illustrate this point, we're going to firstly look at considering Satan and God as kind of living embodiments of a concept and explore using kind of a mathematical analogy how this prevents us being able to talk about them in very specific ways, but it does allow us to illustrate how these beings are far beyond our kind of everyday concepts and how they're very difficult to communicate in any way but in what seems like a slightly mystical, ambiguous manner. And for reference, I am a Satanist, so I do believe in Satan as a spiritual being. With regards to God, I believe that there is a spirit that helped create the universe, and that's what I mean by the word God. That's just for reference. But this kind of idea of exploring them as living concepts can be extended to other beings and entities as well. So, to illustrate the point, I'm going to be referring to something that is used a lot in mathematics, and this is defining something not by what it is, but by some set of generic properties. And we'll see how this interlinks with our discussion of Satan and God in a bit. So let's consider an example. Let's look at the norm. So we define the norm as follows, and this is taken from a book on variational calculus. And the norm is described as follows. So a linear space R is said to be normalized if each element X, which is a member of R, is assigned a non-negative number called the norm of X, such that the norm of X is equal to 0 if, and only if, X is equal to 0. Also, the norm of the product of alpha and X, where alpha is some kind of constant, is equal to essentially the magnitude of alpha times the norm of X. And also, taking the norm of X plus Y must give you something that is less than or equal to the norm of X plus the norm of Y. Now, this is a very abstract thing. By the way, a linear kind of vector space is something that we deal with a lot in physics, so we can just take a linear space to be any space for now. There are kind of specific sets of axioms a linear space has to obey, but for now, let's just kind of think of it as, you know, a kind of space. And we take X to be an element of this space, and we assign X a non-negative number, and we call this non-negative number the norm if it assigns certain axioms. So we might look at this and go, well, we have defined a specific thing called the norm. But if we look, we actually have a list of its properties. So we are defining something, but when we go, well, how does this something exist in our physical world? Suddenly we see that there are many ways in which this exists. So an example is, you know, if let's say my linear space was a space full of, you know, arrows, well, we could say the length of the arrow is what we will call the norm of the arrow, because the length of an arrow is 0 only if all the components of the arrow are 0. Equally, if we kind of multiply all components of the arrow by that, say, 3, then the arrow we end up with will be 3 times the size of the original arrow. And equally, the arrow, if we think of it as kind of the hypotenuse of a right-angled triangle, the diagonal length of the arrow will always be less than or equal to the kind of sum of its components. That's just kind of a property of the hypotenuse of a right-angled triangle. And so the third axiom is obeyed. Therefore, length of an arrow is an example of what we can consider the norm. But this isn't the only way that the norm becomes manifest in the physical world. So as we've said, the norm defines the length of an arrow and thus refers to kind of distances of kind of real things. We can draw a group of arrows on a sheet of paper and we can use this norm to describe lengths and distances. But we can also use the norm to define distances of functionals. Now, functionals are not arrows, they're something completely different. They're essentially integrals of families of functions, so something very abstract, completely different set of arrows, but we see that the norm we can define for kind of very real, tangible things and also very abstract things, and the norm takes many guises. So the norm can be thought of as a way to describe all distances, but not just distances associated with things separated by a physical distance. It also describes weird and abstract things such as distances between functionals. So the norm is kind of like the godhood of all things that refer to distance. So kind of I'll call the most perfect, the most generic embodiment of something a god of that thing, or else the perfect form. And this is very much related to Plato's kind of analogy of the world of the forms, and that there are perfect forms of things. And he even refers to, the ultimate form as good, almost like a Christian might refer to the Judeo-Christian God. So the perfect form, the ultimate form of something is what I will call a god. And in this way, we might consider the norm as the god of distance, because it embodies, by its axioms, it encapsulates all the properties of distance, and yet it has many ways in which it can appear and become manifest in the world. Kind of physical distance is only one of those. So we can extend the idea of distance into something much broader, and we will call this thing the norm. And in a similar way, that kind of the norm is the god of distance, we can think of Satan as the god of freedom, or the Judeo-Christian God as the god of creation. So Satan and God, they both are kind of are generic concepts like the norm. We can talk about specific ways in which they become manifest, and in that they are more tangible, but they are not so much a specific concept as a kind of generic, perfect encapsulation of all things conceivable associated with something. They're very vast and are very abstract, and they are just as abstract as the norm or other weird mathematical concepts, or perhaps even more abstract than those. And that is why it is very hard to talk about the specific details of God or Satan. And I hope this kind of analogy that we see in mathematics is helpful for explaining this a bit further and explaining why often it seems mystical when we talk about Satan and God. Because if I talked about things like norms in terms of the axioms I have listed associated with it, those 3 axioms we saw, then my description of the norm would seem very abstract, very otherworldly, but that is because it's trying to explain a thing which has many different manifestations in the world. And the same is true for Satan or for God. Thank you very much for watching. Wishing you many satanic blessings and hopefully see you for more soon. Thank you.